Okay, let's look at this example now. Here it says to evaluate each expression. Now they give us that f of x is the polynomial 2x squared plus 3x plus 4, and g of x is the polynomial 5x cubed plus 1. So we're going to add together f of x and g of x. Now personally, even though we could write this out horizontally like they're showing us here, when we're adding or subtracting polynomials, personally I think it's easier to do it vertically. Here's what I mean. So first off, let's write down f of x, which would be 2x squared plus 3x plus 4. Now we're going to add to that function g. So what I want to do is I'm going to add 5x cubed plus 1, and I'm going to line these up so we have our like terms together. So I'm going to put the 5x cubed underneath the other x cubed. Well, if you notice, there is no other x cubed, so I'm going to put that way over here. And the plus 1, now that does not have a variable, so I'm going to put that underneath the other number, or the other term that doesn't have a variable, from f of x. Now we're going to add these together. So 5x cubed, there's nothing to add to that, so my answer is just going to be 5x cubed. 2x squared, we can see there's nothing to add to that. Same with the 3x. And the 4 plus 1, we can combine those like terms and get 5. And that would be your answer. Now the same thing is true with subtraction, but it's a little bit trickier. So we're going to start out with do this so we can make sure we don't get confused here. But we're going to start out with the 2x squared and 3x plus 4. That's our f of x. Now we're subtracting from that g of x. Now we're subtracting every term. So the fact that this is 5x cubed plus 1 means I have to subtract 5x cubed, and I have to subtract the 1 from those previous terms. So I'm going to write this as minus 5x cubed and minus 1. Now if this had been 5x cubed minus 1 at the beginning, I would still write it as minus 5x cubed, but if I subtract a negative 1, I would change it to that case to a plus 1. But that is not what we're working with here, so we would be subtracting 1. And when we subtract these now, I have negative 5x cubed. The 2x squared, there's nothing to subtract from that, so it stays at 2x squared. The 3x, there's nothing to subtract from that, so it stays at 3x. And 4 minus 1 is 3. So that would be my answer for this problem. And these are both in standard form. And the degree for both of these would both be 3. So the degree for the first one is 3, and same thing with the second one. If they ask for the leading coefficient for the first one would be 5. For the second one, it would be negative 5. Now, without completely multiplying these together, let's figure out what the degree of this would be if I were to multiply these two polynomials. So we've multiplied polynomials together actually back in a previous chapter. So if we were multiplying these together, what would happen is I'd end up multiplying and distribute the 2x squared to both of these numbers. Then I would take the 3x, multiply that times both of those numbers, the 4, multiply that times both of those numbers, and so on. But we'd end up getting the degree. Remember, the degree is the largest exponent. Now when we multiply, and the bases are the same, remember we add the exponents together. So what I would do is if I took 2x squared times 5x cubed, I'd end up getting 10x the fifth. So 2x squared times 5x cubed would end up giving me 10x the fifth. So if you notice, when I multiply those together, my degree ends up becoming 5. And the leading coefficient would be the 10. So all you have to do when we're multiplying two polynomials, take the term with the largest degree from the first polynomial, take the term with the degree from the second polynomial, multiply those together, and that would give you your leading coefficient and the degree of the polynomial, which is summarized here in this next paragraph, which says the degree of the product of two polynomials. So again, when multiplying, the degree is going to be the sum of the degrees of the polynomials. Because here I had a degree of 2, here I had a degree of 3, add those together, we get 5. And the leading coefficient of the product of two polynomials is the product of the leading coefficients of those polynomials. So 2 times 5 gave me 10. Let's look at some other examples. Here they give us function f is 2x squared plus 3x plus 4, and function g is 5x cubed plus 1. Now it says write an unsimplified expression for f following g of x. Now remember, from composition of functions, this means we put function g inside of function f. So everywhere that I see an x in function f, I'm going to replace it with 5x cubed plus 1 because function g is my input for function f. So in other words, I would have 2 times x, which is going to be 5x cubed plus 1, that would be squared, plus 3 times my input, which is 5x cubed plus 1 plus 4. So this is the unsimplified expression. Now we want to use that to find the degree of this polynomial when I would actually go through and multiply all these together. Now you're going to get the degree from this piece right here. So remember, if I square something, that means I multiply it by itself. So in reality, I'd end up taking 2 times 5x cubed plus 1 times 5x cubed plus 1. Or we could also use the binomial square theorem here. But I don't want to have to go through and multiply all this together because I just want to find the degree. So we know that we would get the degree by multiplying these pieces together. So remember, from that previous paragraph, we would just add these two degrees together. 3 plus 3 would be 6. And the leading coefficient we would get by multiplying these two together. But don't forget, we also have to include that 2. So if I multiply all those together, 5 times 5 is 25, and 25 times 2 would be 50. So my leading coefficient would end up being 50. Let's look at another example. Here they give us function f is 3x squared plus 2x plus 1, and function g is 4x minus 5. We want to find the degree of these two multiplied together. So again, the trick is that if we want to find the degree, we would just add these two degrees together. So the degree for the first polynomial is 2, the degree for the second polynomial is 1. Add those together, we get a degree of 3. To find the leading coefficients, that's where we would multiply the leading coefficient for each polynomial together. And 3 times 4 would give us 12. And the degree of f following g of x, remember that would mean that what I would do here is I would be taking, if it's f following g of x, I'd put this function into each of these. So remember, what we'd end up having is we would get the degree from the part, that would be 3 times my input, 4x minus 5 being squared, which means the same as 3 times 4x minus 5 times 4x minus 5. So to find the degree of this polynomial, the fact that this degree here is 1, this degree here is 1, if I add those together, I get a degree being 2. My leading coefficient I would get by multiplying these pieces together, and we also have to include the 3. Well, 3 times 4 is 12, times 4 is 48. So the leading coefficient would end up being 48. Why don't you guys pause the video and try this next one on your own. So this time we're working with the polynomials where f of x is 5x cubed minus 3x squared plus 4, and g of x is 2x plus 6. So why don't you guys take a couple minutes and find the degree and leading coefficient for each of these, for A through D. So pause the video and hit play when you're ready to check to see if you have the correct answer. Okay, let's see how you did here. So for the first one, to find the degree for each of these, or for this polynomial, when you'd multiply them together, for the product of those two polynomials, I should say, we would, remember, take the degree for the first polynomial and the second polynomial and add those together. So the degree for the first polynomial is 3, the degree for the second one is 1. Add those together, we get 4. So the degree of the product of these two polynomials would be 4. The leading coefficient of the product of these two polynomials, we would take the leading coefficient from the first polynomial, add that to the, multiply that by the leading coefficient of the second polynomial, and 5 times 2 would be 10. Now to find the degree of f following g of x, remember g of x then would be your input for function f. And all we would care about is inputting that 2x plus 6 into that first term. And so when you do that, you'd end up having 5 times 2x plus 6 quantity cubed. Now, if you're wondering, well, what would we do with the 3x and the 4? Well, you would still, technically, if you wanted to find f following g of x, you'd still put 2x plus 6 in there. It's just that for the purpose of this problem, we're just looking for the degree, so all we care about is that first term. So remember, to cube something, it means you multiply it times itself 3 times. So this would be the same as 5 times the quantity 2x plus 6 times 2x plus 6 times 2x plus 6. So from that, we can find the degree. Because since each of these x's have an exponent of 1, the degree here, we would add those together, 1 plus 1 plus 1, and get 3. The leading coefficient, we're going to get that by multiplying together the coefficients, the 2's all together, times that 5. And when you do that, you end up getting your answer, which would end up being 40. So that would be your leading coefficient. Let's look at some other let's look at some story problems now. So this one says Anita Lone and her family start saving for college when she graduates from 8th grade. At the end of each summer, they deposited money into a savings plan with an annual percentage yield of 5.8%. Anita is planning to go to college in the fall following her graduation from high school. How much money will be in the account when she leaves for college if no other money is added or withdrawn? Now we have to use our exponential equations that we've talked about before, where we have our initial amount, our a, times our growth factor b to the x power. So remember, the initial amount is referring to, in this case here, your first initial amount would be 1,200. And you multiply that times your growth factor. Now it's growing by a percentage of 5.8% each year. So remember what we have to do with that percent. We take that percent, we add it to 100%, because we're going to have that, so that 5.8% is what's going to be added on to what we would have previously, 100% of what we had previously. So we'd have 105.8%, which as a decimal is 1.058. That's what we need to use as our growth factor here. Now this money is going to be sitting, so this $1,200 she gets in the summer after her 8th grade year. So it's going to be sitting for 1, 2, 3, 4 years before, because after the summer of her 12th grade year, she's starting college. So it's sitting for 4 full summers, or 4 full years. So your exponent would be 4 here. Then we would go to our next piece. The next piece would be the $850 times our growth factor, which is still 1.058. But this time, this is sitting for 1, 2, 3 full years, plus our next amount, the 975 times 1.058. That's going to be sitting for just 2 years, just for these two. And then we would add to that the 1,175 times 1.058 to the first power, because that's going to sit for 1 full year, plus the 1,300. Now that's not going to be gaining any interest at all. We're just going to put that $1,300 into the bank, and that's not going to be gaining any interest. And so if you type all of this in your calculator all at once, you end up getting your answer, and your answer would end up being $6,144.74 is how much money she would have at the start of her first year of college. Well, why don't you guys go ahead and try this next one on your own. It's the same concept, so you're going to be using the same equation, a times b to the x power. And so work this one out to figure out how much money will be in the account when Anita, this first time, it's Anita degree, how much money she'll have when she goes to college. So pause the video and hit play when you're ready to check your answer. Okay, so let's see how you did here. So again, what you would do is you would use that formula, a times b to the x power, where a represents your initial amount, b your growth factor, and x would be your time in years. Now for this first part, your initial amount would be the $2,000. And for all of these, your growth factor, you would take that 4.2%, add 100% to it to have 104.2%, then change it to a decimal to get 1.042. So then, as you go through this problem, you would have, for the first example, or first term, you'd have 2,000 times that 1.042 to the 4th power, And the reason for it being the fourth power is because that $2,000 is going to sit for 1, 2, 3, 4 years, because she's entering college right after 12th grade. And then the next one would sit for 3 years, the next amount for 2 years, the next amount for 1 year, and that $2,100 is not going to earn any interest. And when you do that all in your calculator, you should have gotten $11,810.96. Well, that's it. So hopefully now you have a better understanding of how the degree and the leading coefficient work. And then for this last problem, hopefully you understand how now you can apply that a times b to the x power to create a polynomial and to figure out your answer. So with that, good luck now as you work on your assignment.